us continue with one more problem on Cauchy's integral formula. So here is one more, that is evaluate integration of the curve C f of z dz divided by z square minus 4 over the curve C. Curve C are the first curve this, then next this, then already we have solved one problem of this type. Now I have to first discuss along with that. First we'll take the initial points. The solution goes as, okay, so we are given with, yes, 1 divided by, first let us consider what is this. Okay, this is nothing but 1 divided by z minus 2 into z plus 2. What do you say? Right, now let us take partial fractions of this. Okay, how do you take? It is a divided by z minus 2 plus b divided by z plus 2. If you do that, what do you get? Yes, first resolve this into partial fractions. Okay, to resolve them into partial fractions, let us consider the first part. 1 divided by z minus 2 into 1 divided by, okay, plus into z minus 2 is, z plus 2 is a into z plus 2 plus b into z minus 2 divided by z minus 2 into z plus 2. These two will get cancelled. You have 1 is equal to a into z plus 2 plus b into z minus 2. Okay, now this is 2 over here. Okay, don't get confused. Now if you put the value for z as minus 2, if z is equal to 2 first, I'll take, if z is equal to 2, you will get a is 1 is equal to 4 times a, or a will be 1 by 4. Similarly, if z is equal to minus 2, 1 will be equal to, this is 0, this you will have minus 4 times b, or b will be minus 1 by 4. So I can rewrite the given thing as 1 divided by z square minus 4 is equal to, the value for a is 1 by 4 into 1 divided by z minus 2, minus the value for b is minus 1 by 4, so it is minus 1 by 4 1 divided by z plus 2. This is what you get. Okay, the two resolved fractions. Once you get these two resolved fractions, now let us write what is integration of the curve C dz divided by z square minus 4. It will be equal to, yes, I have to substitute the values now of these. So it will be integration of the curve C dz into 1 divided by 4 and all that. So I can write it as 1 divided by 4, 1 divided by z minus 2, minus 1 divided by 4, 1 divided by z plus 2, this into dz you have. Now separate the integrals because there is minus sign in between and rewrite them. I shall do it here itself. So I can write it as 1 by 4 constant integration 1 divided by z minus 2 dz minus 1 divided by 4 integration of the curve C dz divided by z plus 2. Like this you must be getting. Okay, so I'm going to call this as I1 minus I2. Okay, now we have got 2 points. Okay, coming to the first part, you are given with the first curve as mod z is equal to 1. Mod z is equal to 1. Now this represents a circle with center as the origin and radius 2 units. Okay, 2 units. Radius, the center as the origin and radius 1 unit. Okay, I'm so sorry, it's a unit circle. Now you see that it will be a circle like this. X-axis, the imaginary axis, the origin. You have radius 1, 1, 1, 1. And look at the points we are having. There are 2 points here. Okay, a is equal to 2 and a is equal to minus 2. Z minus 2 gives you a is equal to 2. Z plus 2 gives you a is equal to minus 2. Now both the points, these 2 points, a is equal to 2 will be here somewhere. Right? If 1 is here, 2 will be somewhere here. A is equal to minus 2 will be somewhere here. Now both of these points lie outside the given curve C. This is my curve C. Right? So therefore this implies the 2 points lie outside mod z is equal to 1. If it is lying outside, what do you mean by that? This implies integration over the curve C 1 divided, dz divided by z minus 2 is 0. Similarly, integration of the curve C, since z is equal to 2, a is equal to 2 is lying outside the curve, so it will also be 0. And also this point dz is also 0 because even this point is lying. Now when both are 0, therefore integration over the curve C dz divided by z square minus 2 is equal to 0 for this particular example. And make a note here, f of z is 1. Anyway, this f of z was not used because both of the points were lying outside the circle. Okay. Now coming to the second point, you have mod z is equal to 3. Okay, and you have f of z is equal to 1, that is the upper part of the function of the given integral. Okay, now mod z is equal to 3 means this is x-axis, y-axis, imaginary axis you have, and then you have a circle. So just a minute. Okay, so this is 3 units. This represents a circle. See, the radius is 3 units here. Center is the origin, radius is 3 units. So I'll redraw it once again, a minute please. It's not a proper figure. Yes. If this is 3 units, the radius is 3 units here, and you see the center is the origin, radius is 3 units, means plus 2 comes here, minus 2 comes here, this is 3, right? So both the points lie inside the circle, right? So maybe close to that, okay? But see here, both the points plus 2 and minus 2, they both lie inside the circle, okay? This right here clearly. Here a is equal to 2 and a is equal to minus 2 lie inside mod z is equal to 3, okay? So therefore, by Cauchy's integral formula, what can you evaluate the Cauchy's, since f of z is equal to 1, it is constant. Therefore, by Cauchy's integral formula, integration of the curve C, I am going to evaluate first I1. I1 is equal to 1 by 4 integration of the curve C, f of z divided by z minus 2. So f of z is 1 here, so it is dz, okay? dz divided by z minus 2, it is equal to 1 by 4 as it is. By Cauchy's integral formula, it is 2 pi I into f of 2, right? Okay, because a is equal to 2. So therefore, it will be 1 by 4. F of z is 1, so f of 2 will also be 1. 2 pi I, this is 1 into 1, you can write, or it is pi I by 2 you get. Similarly, I2 is 1 by 4 integration of the curve C, z dz divided by z plus 2 here, so it is 1 by 4, 2 pi I into f of minus 2 you get. F of minus 2 is also 1 because f of z is also 1, so 1 by 4, 2 pi I into 1, or it is pi I by 2. Therefore, I shall solve the rest part here for this problem. Look at this. Therefore, integration, no, that is not enough space. Okay, wait a minute, let me clear it for you. So we got therefore integration of the curve C dz divided by z square minus 4 is equal to I1 minus I2. I1 we got I pi by 2 minus I pi by 2, which is 0, hence the complete solution. Okay, now we will go for the third part. What is the third curve? We have third curve. Let me see the question there. You have third curve, mod of z plus 2. Third one, mod of z plus 2 is equal to 1. Now this is also a circle with center at, can anyone tell me what is the circle? It is as good as writing z minus of minus 2 is equal to 1. Okay, so the center is minus 2 comma 0. So let's draw that circle. Minus 2, say if it is 1, this is minus 2, okay, and radius is 1 units only, this is minus 2, okay, this is 1 unit. So this comes the circle like this, okay, the radius is 1 units, this is also 1, Okay, this is also 1. Okay, 1 1 1. Okay, and the point is -2, the center is -2. Okay, x-axis, y-axis, and the origin, you see that. Okay, so clearly yes, a is equal to, the point a is equal to -2 lies inside the circle, yes or no? The circle, inside the circle, z mod of z plus 2 is equal to 1, and the point a is equal to plus 2 lies outside. So it implies for I1 you can have the value, right? For I1 you can have the value, but for I2, yeah, sorry, where we are having for I1 and I2, please check. I1 we had got, it was 1 by 4 integration over the curve C mod z divided by z, dz divided by z minus 2, and I2 we had got 1 by 4 integration of the curve C dz divided by z plus 2. Okay, so z is equal to a is equal to -2 comes here. Okay, so this point z is equal, a is equal to 2 lies outside the circle, so for this I1 it will be 0. Okay, but for this it will be 1 by 4 as it is by Cauchy's integral formula, 2 pi I f of -2 you get. Again, since f of z is equal to 1, it is fixed. Okay, so since f of z is equal to 1, this is into 1, or it is you get pi I by 2. Pi I by 2. I2 you are getting pi I by 2. The first part is 0. Therefore, integration of the curve C dz divided by z square minus 4 is equal to I1 minus I2 you should get. So I1 is 0 minus pi I by 2, or the final answer is minus pi I by 2. Hence the complete solution for this problem. I hope it is clear to all of you. Continue in my next session with one of the important problems from these. Already these type of problems have appeared in the previous year question paper, so pay attention all of you and try to solve as many as problems that you can do on this topic. Okay, continue in my next session. Thank you.